In this lesson, we will examine the fly-by-wire flight control systems in use on many of the most modern large aircraft. Mechanical and hydromechanical flight control systems are heavy and require careful routing of flight control cables through the aircraft, using a system of pulleys and cranks. They also require a lot of maintenance in the form of lubrication, tension adjustments, and so forth. These systems have a very limited ability to prevent dangerous characteristics such as stalling or spinning. Electronically controlled flight controls in systems known as fly-by-wire systems overcome many of these problems. By using electrical control circuits combined with computers, designers can save weight, improve reliability, and use the computers to prevent undesirable aerodynamic characteristics. Between the pilot and the final control actuator, a computer system is interposed. This modifies the pilot's inputs in accordance with carefully developed and validated software programs in order to produce maximum operational effect without compromising safety. The pilot's commands are converted to electronic signals. These signals are passed to the flight control computers, which determine how best to move the actuators at each control surface to provide the desired response. The actuators are still usually hydraulically operated. The computer monitors the aircraft's response to the flight control movement and modifies its output to the powered flight control unit as required. All Airbus aircraft since the A320 series have used fly-by-wire controls. Boeing have followed with their 777 and later designs. Side sticks, or conventional control yokes or wheels, are used in fly-by-wire aircraft. The side stick offers the advantages of being lighter, mechanically simpler, and unobtrusive. Standard rudder pedals are used. Boeing consider the lack of visual feedback from the side stick a problem, and so use conventional yokes in their fly-by-wire designs. The Airbus series have used side sticks extensively, and the new Airbus A380 uses them. The main concern with fly-by-wire systems is reliability. While traditional mechanical or hydraulic control systems usually fail gradually, the loss of a flight control computer could immediately render the aircraft uncontrollable. For this reason, fly-by-wire systems incorporate either multiple redundant computers, some kind of mechanical or hydraulic backup, or a combination of both. The Airbus A320 fly-by-wire system is a fairly typical system, so we will now take a look at its features. There are 7 computers and 3 hydraulic systems looking after the primary flight controls. Each primary flight control has 2 hydraulic actuators, each fed from one of 3 independent hydraulic systems. There are 2 elevator aileron computers, or ELACs. These control the elevators, ailerons, and stabilizer. Only one of these computers is controlling at any time. The other is a backup and will automatically take over in the case of a failure. There are 3 spoiler elevator computers, SECs. They control the spoilers. And in the event of failure of both elevator aileron computers, they will also control the elevators and stabilizer. Although the pilot controls the rudder through a conventional hydromechanical system, there are also 2 flight augmentation computers, FACs, which operate the rudder to automatically give roll assistance. The stabilizer trim is hydraulically operated. It can be mechanically controlled by the pilot's trim control wheel. This system has both electrical and hydraulic redundancy built into it. The elevator and ailerons have access to up to 5 computers, only one of which is needed for them to operate. The aircraft has 3 hydraulic systems. Each control surface can be operated by either one or 2 of these systems. Even if 2 of the hydraulic systems fail, the aircraft will still be controllable. In the event of a total electrical failure, the aircraft can be controlled longitudinally with the trim wheel and laterally with the rudder pedals, both of which operate their control surfaces hydromechanically. To summarize fly-by-wire systems, they are lighter than conventional systems, and they improve the control of the aircraft throughout the flight envelope. As with conventional systems, they have a great deal of redundancy built into them.